Okay, here is a video guide for lesson 4.1.1, constant ratios in right triangles. And it says here in chapter 3 we were looking at triangles and determining similarity or congruency based on those conditions we discovered. Now here what we're going to do in the beginning of chapter 4.1 is we're going to look a little more closely at slope triangles. And we're going to try to catch a pattern here in this first lesson between the ratios in the slope triangles and the angles of the slope triangles. And see if those can tell us something as we move forward throughout chapter 4. So the first one here, you can see they have a slope triangle and an angle they're telling you is 11 degrees. Now it tells you to draw 3 new slope triangles and each should be a different size. And so what I do here and what I recommend you do is you start at this point and you try to draw new slope triangles. And so this one here, I could go out this far up 2, so that's 10 and 2. Over 10 up 2, and then I could do another one starting in that same spot, and I could probably go over this many up here, so I have another slope triangle, and this one I think is over 15 up 5. And we can explain why we believe, because we did this in chapter 3, why we believe this red, blue, and original are similar, okay? And then it says since they are similar, so they must be, we can explain how we know, but since they are similar, what can we say about their slope ratios, right? And the way that we can see slope ratios is like rise over run. And so in that first one, you would have 1 divided by 5 is your first slope ratio. And then we'll find out these other ones. So the blue one could be like 2 and 10, the red one 3 and 15, and see if you can see what can you tell about those ratios, okay? And be as specific as you can, really try to catch what's happening there, okay? And then we're going to confirm our conclusion from part C by writing the slope ratios for each triangle as a fraction. And that's kind of what I was doing here in part C as it was. Okay, and then we can actually determine if we change it to that ratio into decimal form, we can compare what's happening even more closely. Okay, what we have here is Tara thinks she saw a pattern, and I think you will too, and we're going to investigate if that pattern remains true. And it says, what if I drew a slope triangle on that same line? So saying drew a slope triangle on this same line, and she had a change in y that was equal to 6. What would the change of x have to be then? Okay, and so what I do here takes me back. If these triangles are similar, we should be able to use equivalent ratios. And you could say, well, in my first triangle, I had a change in y of 1 and a change of x in 5. And so I can use equivalent ratios here and say, okay, 1 divided by 5 must equal my other ratio, which could be a change in y of 6. So I have 6 on top, and then I'm looking for what x would have to go on bottom with it. Okay, so it's just equivalent ratios. If you could even want to draw it out, you'd have a triangle, this 1, 5 triangle, and then you would have like a change in 6 triangle and an x that you don't know, so you'd have to solve for it. Okay, another way, so then the other question is kind of changing it, so that was change of y is 6. We now have a change of x of 40, and you can do a similar thing. You can use 1, 5 as your equivalent ratio, set it equal to it. It's going to look a little different because now you're talking about a change in y of 40. And then you could solve it for your y, really, and then have your change in y that goes with that 40 change of x. Okay? The next question leads into the following. So it says, what if I draw a slope triangle on a different line? Can I still use this ratio? So like, can I still use 1/5 to figure out my x and y missing value? Or is 1/5 specific to this line? All right, so you're going to draw a conclusion here, and we're going to test it on the next slide. So you go here, and it says, what if I do draw a different triangle, or I draw my triangle on a different line? So the first thing we need to do is graph this line 2/5 x, which means starting at the origin, I go up 2 over 5. So 1, 2, 3, 4, 5. Up 2 over 5 again, 1, 2, 3, 4, 5. And then I'm just going to draw my line the best I can from here. Okay. I can draw a couple of, so I can draw in my line, and I can look at what my slope ratio is by creating a triangle. So if I go over this 5 up 2, I can create my slope ratio, which is 2 over 5 because of up 2 over 5. Okay, and then it says, what does the angle appear to be in this line? And we can support our conclusion. And so it's saying, what do we believe the angle here to be? And we don't really know. We don't have a tool right now to figure that out. But what I will say is take a look at the difference in, here we had an 11 degree angle, and that was 1/5. Now we have 2 over 5. What do you think happened to the angle? Okay, so it looks like the fraction got twice as big. What do we think happened to the angle? And you can explain there, and then you can explain if it backs up what you were saying in part C here. Did you think that it was going to get the same exact triangle or not here in that box? Here's a good one. I really like this problem. And so what you can do, you have to drag your protractor down so that it lines up here on point P. And you can see like the 0 is right on the green line, the Q line. And then I want to move my R so it forms an 18-degree angle. So as best as I can, right about there. Okay. And then it's going to ask us to find the slope ratio. And so, well, I can go over 1, 2, 3, up 1. That's a slope ratio of 1 over 3, because up 1 over 3. Kind of interesting just to use that little virtual protractor, I think. Okay. Then we're going to graph a line, talk about the slope ratio of this line, and then we're going to try to say, okay, what would that slope angle have to be? And then we get to kind of draw some conclusions from what we noticed. Did all triangles have a slope ratio of 1/5? If the slope ratio is 1/5, is the angle going to be approximately 11 degrees? What about if it had an 11-degree angle? Is it going to be approximately 1 over 5 for the slope ratio? And do different lines have different slope angles and different slope ratios? Okay. Now, if there's anything throughout that lesson, make sure you email me and ask. Also, hopefully you joined the live lessons this week and got some help where you were stuck. Okay. Again, please reach out if you need more assistance.